2.7 Solving linear inequalities. Less than, greater than, less than or equal to, greater than or equal to. When we are solving equations, we have to do something to both sides of an equation to get the letter alone. We know that if we do the same thing on both sides of an equation, it is still equal. Now we will be solving inequalities. What happens when you do something to both sides of an inequality? Does it stay the same? Let's check by taking some true inequalities and doing the same thing on both sides. We will go through adding, subtracting, multiplying, and dividing. Example 1. 2 is less than 5. Add the same number to both sides. Just pick any number. Add 3. 2 plus 3, 5. 5 plus 3, 8. 5 is less than 8. This is true. We can see that when you add the same number on both sides, it stays the same. The inequality, the less than. Example 2. 2 is less than 5. This is a true inequality. Subtract the same number on both sides. Just pick any number. 2 minus 1, 5 minus 1. 1 is less than 4. This is true. 1 is less than 4. When you subtract, it stays the same. Less than stayed. Example 3. 2 is less than 5. Multiply both sides by a number. 2 times 3, 6. 5 times 3, 15. This is true. 6 is less than 15. We can see that when you multiply by a positive number on both sides, the inequality stays the same. Example 4. 2 is less than 5. This is a true inequality. Multiply both sides by a negative number. Pick any number. 2 times negative 3 is negative 6. 5 times negative 3 is negative 15. Is negative 6 less than negative 15? This is not true. Negative 6 is more than negative 15. What is true? Negative 6 is greater than negative 15. Negative 6 is bigger because negative 6 means $6 in debt. Negative 15 means $15 in debt. $6 in debt is better than $15 in debt. We can see that when you multiply by a positive number on both sides, the inequality flips. It turns the other way. Example 5. 10 is less than 15. This is a true inequality. Divide both sides by a positive number. Pick an easy number. 10 divided by 5 is 2. 15 divided by 5 is 3. 2 is less than 3. This is true. We can see that when you divide by a positive number on both sides, the inequality symbol stays the same. Example 6. 10 is less than 15. This is a true inequality. Divide both sides by a negative number. Pick an easy number. 10 divided by negative 5 is negative 2. 15 divided by negative 5 is negative 3. Negative 2 less than negative 3. This is not true. Negative 2 is more than negative 3. Negative 2 means $2 in debt. Negative 3 means $3 in debt. $2 in debt is better than $3 in debt. Negative 2 is greater than negative 3. We can see that when you divide by a negative number on both sides, the inequality symbol flips. It turns the other way. When you multiply or divide by a negative on both sides, flip the inequality symbol. The entire part of the rule is important. Now we will use what we learned above in the last slides to solve inequalities. We will still do the same thing on both sides of the inequality. We still use the undo operation, meaning undo, add with subtract. We still get the letter by itself. We must decide if the symbol changes or stays every time we do something to both sides. Example 1. Solve. X minus 5 is less than 10. Add 5 on both sides to undo subtract. 10 plus 5 is 15. The symbol stays. Solve. X plus 3 is greater than 5. Undo add with subtract. When you subtract, the symbol stays. Example 3. X minus 4 is less than or equal to 9. Undo subtract with add. The symbol stays when you add. 2x is less than negative 10. Undo multiply by 2 with divide by 2. Negative 10 divided by 2 is negative 5. The symbol stays. We divided by a positive on both sides. Example 5. Negative 2x is less than 10. Undo, multiply by 2 with divide by 2. The symbol flips since we divided by negative 2 on both sides. 2x plus 3 is less than 15. Subtract 3 on both sides. The symbol stays. 15 minus 3 is 12. Divide by 2 on both sides. The symbol stays because we divided by positive 2. 12 divided by 2 is 6. Example 7. We undo add 3 with subtract 3 on both sides. We subtracted, so the symbol stays. 43 minus 3 is 40. Now divide by negative 2 on both sides. When you divide by negative 2 on both sides, the symbol turns the other way. 40 divided by negative 2 is negative 20. Remember, since we're undoing multiply by negative 2, negative 2x, we have to divide by negative 2x so that we just get x. Example 8. First, we're going to distribute. 3 times 3x, 9x. 3 times 2, 6. 2 times x, 2x. 2 times negative 4, negative 8. This time we have letters on both sides. So, I like to get rid of the smaller one, so subtract 2x on both sides. We're subtracting so it stays. 9x minus 2x is 7x. Bring down the plus 6. On the right, 2x minus 2x canceled. Bring down the minus 8. Now we have 7x plus 6. We want to get x by itself. Subtract 6 on both sides to undo the plus 6. Since we subtracted, it stays. Minus 8 minus 6 is minus 14. 7x is greater than negative 14. Divide by 7 on both sides. The symbol stays the same because we divided by positive. Example 9. Distribute negative 2 on both sides. Negative 2 times x, negative 2x. Negative 2 times 3, negative 6. Now, the symbol stayed the same. The symbol stayed the same because we didn't multiply by a negative on both sides. That's why I said all parts of the rule are important. Okay, we didn't multiply by a negative on both sides. All we did was rewrite the left. Okay, we're going to undo subtract 6 with add 6. The symbol stays. 14 plus 6 is 20. Now we need to divide by negative 2 on both sides. Flip the symbol. Okay, I flipped the symbol there when I did my division because what did I do? Divided by a negative 2 on both sides. Okay, the original problem was greater and now it's less because we divided by a negative on both sides. Example 10. You have $100 cash, no credit, no debit card. You want to know what you can buy so that with tax, it's 100 or less. Tax is 7%. Let X equals the amount the item is before tax. To find out how much the tax is, multiply the item times 0.07. X times 0.07 equals 0.07x. So the tax is 0.07x. The total cost of the item will be how much it is before tax plus tax. So the total is X, how much it is before, plus the tax, 0.07x. X is understood 1x, so the total is 1x plus 0.07x equals 1.07x. You want the total to be 100 or less, so the total needs to be less than or equal to 100. So replace total with 1.07x. To solve that, divide by 1.07 on both sides. The symbol stays. 100 divided by 1.07 is 93.46. So you can buy something that costs $93.46 or less with the cash you have. That's the end.